So, as mentioned in the email this video is attached to, a car moving at 20 meters per second crashes into a tree. Find the magnitude of the average force acting on the passenger with a mass of 65 kilograms in each of the following cases. Case A is the passenger is not wearing a seatbelt. He is brought to rest by a collision with the windshield and dashboard that lasts 3.0 milliseconds. Case B is the car is equipped with a passenger side airbag. The force due to the airbag acts for 30 milliseconds, bringing the passenger to rest. From our impulse momentum theorem, which again is the change in P is equal to the change in F average times the change in time, and this is where, like I have it set up here, is the F average is the average force acting on the passenger, and the change in T is going to be the time interval during which the force acts. So the change in the passenger's momentum is going to be the same in both cases. But here's the thing that differs is the time interval during which the change occurs. So it takes a it takes a larger force to change momentum in a shorter time interval. So the magnitude of the passenger's initial momentum is going to be our equation here, which is P sub I is equal to M times V sub I. And I plug my values in for that, and I get that it's 1,300 kilograms meters per second. And now his final momentum is going to be 0, so the magnitude of the momentum change is going to be the change in P is equal to 1,300 kilograms meters per second. This momentum change divided by the time interval gives us the magnitude of the average force in each case here. So for the case in part A with no seatbelt, F average is equal to change in P divided by change in time. And after plugging the values in for that, I get 4.3 times 10 to the 5th newtons. And then in case B with the airbag, I get F average is equal to the change in P divided by the change in time. And plugging my values in for that, I get that as 4.3 times 10 to the 4th newtons. And I thought this problem was interesting because everybody drives a car and everybody's concerned with safety issues. So it kind of taught me some stuff. I learned that the average forces required to bring the passenger to rest are inversely proportional to the time interval over which the forces act. So I guess it is a far happier situation, if you want to say, to have the momentum change over as long as a period as possible. That way the forces are as small as possible. And this is, I guess, what the automotive guys do in the safety department to design cars that minimize the average forces on the passengers during certain stops and collisions and stuff. This allows the airbags to spread the force over a much larger area than impact with a hard surface like the windshield or something, which again further reduces the risk of injury.